Chapter 3 is all about fractions and decimals, rational numbers. So a rational number is any number that we can write as a fraction a divided by b, where a and b are integers and b isn't 0. Quick note here that decimals that terminate, which means end, or repeat are rational numbers. We have the ability to write them as fractions. The goal of simplifying fractions is to make the numerator and the denominator relatively prime. And relatively prime means that they're numbers that don't have any common factors other than 1. We simplified fractions ever since you learned how to use them. And yes, you must always simplify fraction answers. So first, let's do some quick simplifying. When we're simplifying, the question is, what can I divide both of these numbers by? So 6 and 9, for example, I can divide them both by 3. My division symbol's a little hard to read. The dots aren't showing up very well. There we go. 6 divided by 3 is 2. 9 divided by 3 is 3. 6/9 is 2/3. 21 and 25. 21 is divisible by itself, which doesn't go into 25, 7, which doesn't go into 25, and 3, which doesn't go into 25. Well, 25 is only divisible by 5, which doesn't go into 21. This fraction is already simplified. Negative 24 30-seconds. It's a bunch of possible numbers that actually go into both of these. And I'm not going to choose the greatest common factor intentionally. So let's say you look at both of these and say, hey, I can divide them both by 4. So we're going to divide the numerator and the denominator by 4. Negative 24 divided by 4 is negative 6. 32 divided by 4 is 8. When you look at these two numbers, your brain should be going, wait a second, we're not done. Because they're both even, which means I can divide them both by 2. Can you simplify a fraction in multiple steps? Absolutely. Negative 6 divided by 2 is negative 3. 8 divided by 2 is 4. Negative 3/4 is the simplified version. The greatest common factor here was 8. If we had divided both numerator and denominator by 8 at the beginning, it was one step. But if you don't see the GCF, it's not a big deal. You are allowed to simplify in multiple steps. We quickly need to talk about place value with decimals, remembering that after the decimal point, from left to right, we go tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, and so on and so on and so on. You must know the names of these places, otherwise the next task, which is converting decimals to fractions, becomes very difficult indeed. So we're going to write each decimal as a fraction. This first decimal is 0.5. That number ends in the first place after the decimal, so that is 5/10. Well, 5/10 sounds an awful lot like a fraction. 5/10. There's a reason for that. It is. All we have to do is take a look at our fraction and say, does this fraction simplify? And of course this does. Both of these numbers are divisible by 5, so 0.5 is actually 1/2. In the directions you see it says mixed numbers are okay. What that means is if you have a whole number part to a decimal, it just carries along as a whole number part to a mixed number. It's what is after the decimal that will convert into the fraction part. So this is 0.37 after the decimal point. That ends in the second place, and the name for the second place is hundredths. So this is 37 hundredths. 37 hundredths. 37 is a prime number, nothing else goes into it, and 37 does not go into 100. That fraction doesn't simplify. So negative 2.37 is negative 2 and 37 100ths as a fraction. 0.8716, no whole number part here, so we'll just have a fraction as we do this. That ends in the fourth place after the decimal point. So if the first place is tenths, then hundredths, then thousandths, this must be the 10,000ths place. So this is 8,716 10,000ths. I'm thinking that both of these divide at least by 4. Possibly a bigger number, but definitely 4. Because if you remember your divisibility rules for 4, the last two numbers of the number have to be either 0, 0, which we have in the bottom, or a 2-digit number that is divisible by 4. In the top, in the numerator, the last two digits are 16. 16 is absolutely divisible by 4. Now, in the interest of saving some time here, I'm going to do this with a calculator. So 8716 divided by 4 is 2,179. I'm thinking that's not going to play nice with anything. 10,000 divided by 4 is 2,500. My instinct is to say that this is done, because I can't imagine 2,179 dividing cleanly, and it does not. 2,179 over 2,500 is the simplified form. No, I don't envision giving you many problems that rough on an assignment or a quiz. So to convert a decimal to a fraction, we just name the decimal part properly. 5/10ths, 37 hundredths, 8,716 10,000ths, and then simplify whatever we have. Write each fraction as a decimal, remembering that a fraction represents division. So this time I'm going to do the division longhand. This is 5/4, which is 5 divided by 4. 4, of course, goes into 5 one time. And when I subtract, I have a remainder of 1. You're not allowed to have remainders. So you have to put in decimal points, which you're allowed to do, and start tacking on zeros. 4 goes into 10 twice. 2 times 4 is 8. We will subtract again. Add another 0 and drop, because I'm not allowed to have a remainder. And 4 goes into 20 5 times perfectly. I now have 0, so 5/4 is 1.25. Next we have 1/6, so that's going to be 1 divided by 6. Straight away, 6 doesn't go into 1, so I need to put in a decimal point and start adding in zeros. 6 goes into 10 one time with a remainder of 4. Drop that down. 6 goes into 40 6 times. 6 times 6 is 36 with the remainder of 4. It's the same remainder. When you get a repeating remainder, you've got a repeating answer. That 6 is a repeater. Not the 1, the 6 itself. Because if I keep doing this, I'm going to change colors here so you know I'm not actually doing this. But if I put another 0 and dropped it, 6 goes into 40 6 times, and that's 36, and I'm just going to keep doing that over and over for all eternity. I would rather not keep dividing 6 into 40 for all eternity, so I'm going to put the repeating bar above the 6 and walk away. This is 0.16 repeating.